In this session, we'll see how to solve inequalities. Before I jump over the question, we need to understand some basic signs, those Pac-Man signs if you remember. So we'll see these kinds of signs in our equations. This is greater than sign. If you're using this sign, you can use it with numbers like 4 is greater than 1, like that. That means the value of 4, the weight of 4 is more than the weight of 1. Alright? And this is lesser than sign. Like we can have 9 is lesser than 20. Right? You understand it pretty well. And this one is greater than or equal to. Suppose we have x which is greater than equal to 1, it means x could be equal to 1, or it could be 2, or it could be 3, 4, so on. It could be equal to 1 also, alright? And it could be greater than 1 as well. So this means our expression could be greater than or equal to some number, okay? Some number or some other function. And this sign means lesser than or equal to. Suppose I say y is lesser than or equal to 10. This means y could be any number. It could be minus 10, it could be 0, it could be 1, it could be 9, it could be 10 also, but it cannot be 11, it cannot be 12, it cannot be any number higher than or greater than 10. It cannot be 1000. That is for sure wrong, because this condition is saying y is lesser than or equal to 10. Alright, so in that way you can do all the problems as well. Now we'll see some problems, and there's also many fundamentals that we'll be doing in this inequalities situations, and you really need to focus. Now suppose we have this question: x plus 3 is less than minus 5. So you can treat these questions like basic equations questions. You can put equal to sign here and solve it. But then you will get answer as x is equal to. But here we have inequality, and x will also be a sort of inequality. But you will be solving these questions like you were solving for equations, like you were solving for x. Here also we'll be solving for x. We need to find the value of x. But here I would say not value. We are more interested in finding the range of x, what all values x can have. So this here, what we can do is we can subtract 3 from both sides, because we want to isolate this term x. So subtract 3 from both sides, it will become x plus 3 minus 3 less than the same operation on RHS as well, minus 5 minus 3. This 3 and this 3, these two 3's will cancel up, and we'll have x plus 0, or simply x, lesser than as it is. Then minus 5 minus 3 will be minus 8. So this means our value x will have lesser than minus 8, or we can say it will have, if we draw the number line, let me draw the number line. If this is our number line and this is our reference 0, because everything is going to be negative. If I start with minus 2 gap, I'll have minus 4 here, minus 6, minus 8, minus 10, minus 12, so on. It will never end to minus infinity, right? So this means x will have all values which are lesser than minus 8, but not 8. It cannot have value minus 8. So we should put a big circle which is not filled up circle. It is open. We can have these two circles, one which is filled up and other one which is not filled up. Since x cannot be equal to minus 8, it can be minus 9, it can be minus 10, it can be minus 1000, it can be minus 99999, so on, whatever number you say, but it cannot be equal to minus 8, it cannot be equal to minus 7, it cannot be equal to 0, it cannot be equal to 2, it cannot be equal to 100. It can take all negative values, but those negative values must be lesser than minus 8, right? So we will put a hollow circle, a circle which is not filled up, and then we'll draw a line with an arrow. And now we will plot what all values can our x have. Then show it here. then simply dock it up and move it. So x can take values which are -8 to -infinity. So x will take all these values which are ranging from -infinity to -8, okay? Because x can be anything. X can be -9, x can be -12, or x can be -infinity also, and this is applicable. But x cannot be -8. Remember that. X cannot be -8 because we are putting x is lesser than -8. We are not putting x is lesser than or equal to -8. No, we are not doing that, because here the inequality is only for lesser than sign. Okay, now let's do some more problems. I know you must be having a lot of doubts in your mind, and I'll clear all of them, don't worry. So now we have x upon -2 is greater than or equal to 2. Here I have equal to, and moreover I have this thing. So now you would be tempted to multiply both equations with -2, and you will get your answer as x is greater than or equal to -4, right? You must be tempted to do that, but this is wrong. Why? I did arithmetic well, it should be right, but this is not true. This is exactly opposite. Why? See here, whenever you multiply the variable with a negative number, whenever you multiply or divide, whenever you do any stuff with odd number of negative terms here, you have to reverse your inequality. So this, when you're multiplying with -2, x upon -2 times -2, you have to reverse your inequality, and then you can do this operation on the other side. This thing is incorrect. This is right. Alright, then this -2 and -2 will go away, and x will be lesser than -4, and this is correct because we had a negative number with x. Okay, because x upon -2, or we can say -x was greater than 2, -x. So how could plus x be greater than -4? That's not true. -x, it could be like, suppose, assume the value of x could be, so when I say this -x upon 2 is greater than or equal to 2, then I can move this 2 here as it is, so it will become -x is greater than or equal to 4. Alright, this is my situation, and you cannot say, and here when you found this x is greater than or equal to -4, this is wrong. I'll prove you now. This -x is greater than or equal to 4. Suppose the value of x is 4, that means -4. That is true, right? And then if I put the value of x as 5, that means -5 is greater than or equal to 4? No, that is wrong. How is that possible? Can -4 be greater than or equal to 4? No. Can -3 be greater than or equal to 4? No. So for values of x having 4, 5, so this thing is incorrect. So how could you say that x is greater than or equal to -4? So in that way, this appears very wrong. So we can't do in that way. That is why we have to reverse the inequality sign. Okay, and if we draw the number line, then we can see better. This will be 0, and this will be -1, this will be -2, this will be -3, this will be -4, this will be -5, so on to -infinity. And now I will start with -4 here. We can straight away do here and fill it up, because it's lesser than or equal to -4, and move all the way to infinity, -infinity. So x can take all values from -infinity to -4. This time you should put a square bracket here, and this will be normal bracket. Why square bracket here? Because it takes the value of -4 as well. X can be equal to -4 as well. In previous question, see here, I put this normal bracket here, normal parenthesis sign. I didn't put the square bracket. Why? Because it couldn't take this value of -8. But here it can take the value of -4. That is why it should be squared bracket. Okay, so the note to be made here is, whenever you multiply or divide x or any variable with negative number, then reverse the inequality sign. I know you won't be able to understand my handwriting or write like doctors. So here, whenever you multiply or divide any variable that you need to find with a negative number, it could be -1, -2, whatever, then you have to reverse your inequality signs. If it is greater than, make it less than. If it is greater than equal to, make it lesser than equal to. If it is lesser than, make it greater than. If it is lesser than or equal to, make it greater than or equal to. Okay, you have to exactly reverse the sign. Keeping this thing in mind, we'll do the remaining questions. So I want you guys to try and then look at the board. Now 2 minus 5x is lesser than or equal to 7. So how to do this one? First, isolate terms containing x. So we have to remove this 2. So subtract 2 from both sides. In subtraction, do not change the inequality. But in multiplication or division, only then change the inequality if you are doing it with a negative number. So here subtract 2 from both sides. 2 minus 5x minus 2 lesser than or equal to 7 minus 2. Now this 2 and 2 will cancel up. Only minus 5x is here and 5 is here. Now we can divide both sides with a negative number, -5, to get rid of -5. And at this time you have to change your inequality. So minus 5x upon minus 5 is greater than or equal to 5 upon minus 5. Okay, this time you have to reverse your inequality because you are dividing with a negative number. So this -5 and this -5 will cancel up and we'll have x greater than or equal to -1. That means x can take all values which are greater than -1 as well as -1. So let's plot this thing on a number line. So our number line will look like this. It will have so many lines. Let's keep our reference 0 here, and this will be -1, this will be -2, this will be 1, 2, 3, 4, 5, 6, 7, so on till infinity. Infinity is towards right hand side and minus infinity is towards extreme left hand side. Of course, you can never judge what infinity number is. For some it could be 10 number, for some it could be millions, and for some it could be trillions. So you cannot really judge what is infinity in reality. Okay, it is always relative to each other. And now our x can take values equal to -1 or greater than -1. That means we can start from here with a full circle because x can take the value of -1, and we'll keep moving all the way till we reach infinity because x can take all values greater than -1. So domain or house of this expression to be true when x takes value from -1 square bracket till infinity. Infinity can never be squared because we don't know exactly what the value of infinity is. We have no idea where is the actual value of infinity, so we can never put square bracket here. But here, since this x is starting at -1, x can have this value -1, so we have to put the square bracket here. So this is the domain of x. Now try to do this question. -3x is less than 15. I know this is very easy for you now. Simply divide with -3 both sides, you will get your answer. So it will become -3x upon -3. Notice here, you are dividing with a negative number. So reverse the inequality. 15 upon -3. So this -3 and this -3 will cancel up, and your x will be greater than -5. And if you draw the number line, this will become 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are enough, and this will be minus infinity, and right hand side will be plus infinity, and this, let's assume this is 0, this will be -1, -2, -3, -4, -5, -6, here 1, 2, 3, 4. X is greater than -5, but x cannot be -5. So put a circle, unfilled circle, and move all the way till infinity. So x can take values from -5 till infinity. See here, normal bracket, no square bracket, because x cannot take the value of -5. Now try this question. -7x plus 4 is greater than -3x minus 4. Here, very similar, move all x terms towards LHS and move all normal numbers towards RHS. So move this here and move this to RHS. This will become minus 7x plus 3x greater than minus 4 minus 4. Remember, when you are just shifting the terms or interchanging, not interchanging, when you are shifting the terms, you don't need to change the inequality. But here, when you are switching the terms, like when you are changing LHS to RHS completely, at that time you should switch the inequality sign as well. Now do the basic operation of addition arithmetic here. So this will be minus 4x greater than minus 8. Now you have to divide with a negative number, and at that time you have to change your inequality sign. So this will become minus 4x upon minus 4 lesser than minus 8 upon minus 4. These two will cancel up and x will be lesser than even number of negative signs, so the final answer will be positive. 8 upon 4 is 2. So this will be x lesser than 2. And let's draw the number line. So this will look like this, and then we can mark some points here. And this will be minus infinity, this will be plus infinity, no need to put plus sign. And let's assume this is 0, this is 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, and so on. You can always draw a rough number line like this so that visualization is easier. Put a circle, unfilled circle here at 2, and since x is lesser than 2, that means x can take any values which are lesser than 2. X can be even 1.99999, but x cannot be 2. X can approach 2, but x cannot be 2. And move all the way to LHS, and your domain for x will be minus infinity to 0 in normal parentheses. Do not put the squared bracket. And our next question here, this is minus 6 is greater than or equal to 2 minus 8 times x minus 8. This is our question. We need to find the domain of x. We need to find the range of x. So how to solve it? Very easy, like you did in equation. Keep on opening up the brackets. It will become 2 minus 8x plus 64. And then do normal addition and subtraction. This will become 64 plus 2 is 66 minus 8x. Then you can move the 66 to LHS. This will become minus 6 minus 66 is greater than or equal to minus 8x. This will become minus 72 is greater than or equal to minus 8x. And now I can reverse everything because I want to see my x terms on LHS. So when you are switching the LHS and RHS, you have to shift, you have to switch the inequality sign as well. So this will become minus 8x is less than or equal to minus 72. Or you can simply stick with here, because you can simply see if this minus 8x is lesser than or equal to, because opposite sign is the greater than sign, so you will put this thing. Or you can simply switch it when you're reversing. This is very common sense. It is merely, I'm just moving this minus 8x here and this minus 72 here. So this pointed terms means lesser than, so this minus 8x is lesser than, so I'm just simply writing that. Now I have to divide with a negative number, so I have to change my inequality. So this will become minus 8x upon minus 8 is greater than or equal to minus 7x upon minus 8. Minus 8 and minus 8 will cancel up, and 8 will be greater than or equal to plus 7 upon 8. Oh, this is 72. I'm so sorry. I did a blunder here. Sorry for my bad handwriting. It happened because of handwriting. Always keep your handwriting good. So this will be minus 72, and then that means you have to divide with minus 8. So LHS will become like this, and then inequality will reverse, and then minus 72 upon minus 8. Then simply cancel it up, and your RHS will be positive because minus and minus will cancel up, or you can say even number of negative signs, and 72 upon 8 is 9. So this x will be greater than or equal to 9. Okay, let's do one more question, the last question for day. This is 2 times 3x plus 10 minus 2 is greater than or equal to minus of x plus 3. This is very easy. Simply keep on opening up the bracket. This will become 6x plus 20 minus 2 greater than or equal to minus x minus 3. Solve here. 6x plus 18 is greater than or equal to minus x minus 3. Move this minus x here and move this 18 here. So 6x plus x will become 7x, is greater than minus 18 minus 3 will be minus 21. Divide both sides with 7. Inequality won't change because you are dividing with a positive number. So this 7 and this 7 will cancel up, and x will become greater than or equal to minus 3. And you can graph it on number line if you wish to. X will take values from minus 3. Now this sign, see here, this is also greater than or equal to. So I should have a square bracket here. Minus 3 to plus infinity. Okay. If you have any problems, you can always go back to the previous questions or previous videos, and I hope everything would be clear. In next session we are gonna do combined inequalities, so stay tuned.